Okay, so we are starting with the same topic with which we start in traffic engineering course, traffic flow theory. Okay, and but we will go in more details now. Start from the basics. Okay, but like what I said earlier, try to have some time to go to the videos and the notes. It will be easier. Okay. So what is traffic flow theory? What is any theory? When you say we have theory of relativity, right? We have other theories. So a theory means what? Tell me.
It's like an idea.
Idea.
We haven't put it to the test.
An idea which is not put to the test. Okay. Okay. That makes sense. But when we talk about engineering, we have applied sciences, right? We have applied sciences. Okay, so you can have an idea about sciences or in literature or whatever. Okay, and that's an idea having put into test or something. But when you say we have a theory in engineering, what does it mean? It cannot be just an idea. We are engineers. It cannot be just an idea. It has to be something more. What more? It's an idea. But what more? What are we good at as engineers? Before that, what's in the background? Why we are good at design? Because we are good with we are supposed to be good with what? Calculation, right? Equation, formulas. Okay. So an engineering theory is basically a set of equations by which you are trying to explain something real. Okay, so why is this thing happening like this? Okay, this is the equation which will explain it. Okay, this is called a theory. Okay. So if I burn a fire here and this chair starts heating up, okay, so to explain the temperature rise of the chair, I will have an equation. That's what this engineering theory is. Okay, so it is explaining what is happening in real time. Okay, it is explaining what is happening in real world. So a traffic flow theory is explaining what?
The flow of traffic.
The flow of traffic. Okay, by using what? Calculations. Okay, so these are a set of calculations by which we are trying to explain traffic flow. Clear? Okay. So engineering theory is trying to explain a real phenomenon. So traffic flow theory is explaining traffic phenomena. Okay, and it has to be backed up by equations. So you cannot just say, okay, this will happen, this will happen, this will happen. No. Okay, this is like philosophy. Okay, we are talking about engineering. You must have some basis of what you are saying. There are three main elements of traffic flow theory. Three main elements of traffic flow. Theory is for flow, right? So there are three main elements of flow. Flow, speed and density. Okay, there are three main elements of traffic flow theory, which is flow, speed and density. Okay, so why we have traffic flow theory? What are you reading from here? What are you reading from here? The second one. When you were answering me for it. Okay. So why we need these equations? Because we need to plan, we need to design, we need to evaluate the traffic we have, right? We have to plan for the traffic. We have to design for the traffic. Highways, we have to design the highways, right? And once you have the highways, you have to monitor them. You have to evaluate them. Okay, now they have done something on the highways, which is what? They recently did something new from 1st of February, which was what? You guys should know, right? Up till now you must know where are these cameras, right? Okay, so they started memorizing the locations, right? Where are those cameras? So why did they do this? They must have seen that these are the problems in the people. Okay, these are the problems which are normally happening. Those cameras are more why it is happening. Okay, same thing with the speed cameras and so on. So traffic flow theories tell you or help you in planning for the highways, planning for traffic facilities, designing them, and evaluating their performance, evaluating their effectiveness. Okay, and we will discuss later on the measures of effectiveness. These are some examples where traffic flow theory can, or the equations of traffic flow can help you. For example, you have on a signal a left turning lane. Okay, so usually the left turning lane is not coming from the start, right? When you come near the signal, there is an extra lane. Okay, so how long before the signal the lane should start? You must have seen at many signals in the peak hour, what happens? People are trying to turn left, the lane finished. So now they are blocking the other guy, right? Okay. So I need to design this lane properly. To design the lane, I must know how many. So the signal will remain red for 30 seconds. Let's say. So I must know how many vehicles will come in 30 seconds to design this lane. Get my point? Okay. So how will I know the number of lanes? Using the equations, right? Traffic flow equations. You want to calculate the delay at an intersection or a ramp which is merging on the main highway. Okay, so intersection you have to stop, right? It may be a stop sign, it may be a roundabout, because if you slow down and stop, so there is a delay. How much is the delay? Okay, because this will this delay will tell you, is this a good intersection or a bad intersection, right? More delay is good, right? Bad. So I was thinking, so more delay is bad, but we must know how much is the delay. Okay, and same thing with the ramps. When you are coming from the ramp, there flow on the highway, you have to wait, stop, and slow down, right? Again, there is delay. How much is the delay? You can calculate using these equations. Changes in level of frequency performance due to any traffic control. So we are talking about the cameras, right? Okay. These cameras are, because now you are cautious about the camera, you may drive differently. Okay. My wife gave me a clock. I have to mark where are the cameras and tell her. Okay. So she knows where she has to slow down and where she can go free, fly away. Sorry? Knowing my wife, I am her application. So it doesn't work like this. If I tell her about the application, I have to do double work. Install the application, then see where are the cameras, then tell her. Okay, easier for me, I am going and actually. Okay. So, the point was, I am going to install a new signal. I am going to install a new speed hump. So with this, what will happen to traffic? There are many effects, right? There is not only one effect. Oh, I have a speed hump, I will just slow down. This is the effect which you want. But the drivers may do something else because of the speed hump. They may change the lane. Right? Okay? Or because of the speed hump, maybe you will have more pedestrians crossing now. Getting my point? Okay? So there could be other things which may happen because of what we have done. But how would I know that these things will happen? So I need some formula, some equations. It should tell me if you do this, this will happen. Clear? Okay? So these are some examples, and these are like high level examples. Okay, like they are not simple things to do. Okay, all of them, any of them is not a simple thing to do. Okay, you cannot just imagine. Okay, but even for simple tasks, okay, that we will put a signal, the delay will increase. Okay, but how much will it increase? The value is also important. We are what? Engineers. We cannot just say, okay, increase and decrease. How much? Clear? So that's the point. Okay, so the traffic flow theory is used to study the complex relationships between these three parameters. Okay, when flow increases, what will happen to speed and density, and vice versa. Okay, so if you change any of these parameters, it is affecting the other two. But how much is the effect and how it is affecting? Okay, is it directly proportional, inversely proportional? Is it linear, non-linear? Okay, so these are the things which I are trying to answer in this. Okay. Okay. So traffic flow affects other things which are apart from these parameters. Okay. So for example, traffic flow has accidents, right? Okay. So accident is not part of these three, but because of these three, accidents happen, right? Huh? So traffic flow theory can also include this. Okay. After I was talking about the cameras. Okay. The camera is not for speeding. It's checking if you are using the phone. The phone is causing what? Okay. We have travel time. Obviously, speed and travel time direct relationship. You know, right? The speed increases, travel time decreases. Okay. Air pollution, consumption. Okay. Both of them are related to speed. Your fuel consumption. When you consume fuel, you are creating the harmful gases, right? The burning of the fuel is creating harmful gases. That's why they are coming with electric vehicles and other things. Okay, because they're supposed to have less of this because there is less burning of the fuel. Okay, but what we are using now is direct relationship. Okay, and so your fuel depends upon your speed. Okay, and your fuel, when you burn the fuel, you have air pollution. Clear? Okay, and your speed depends upon what? Flow and density, right? I told you these are interrelated. Okay, so they are affecting each other, and then they are affecting these other things. So you can see now crash related to human life. Okay, it has social aspects. Travel time, it affects your productivity. Okay, now with the new camera you cannot even use the phone. Imagine you're stuck in traffic for half an hour without the phone. Okay, so good practice. Environment, natural resources. Okay, so it's not only talking about a simple traffic jam. We are talking about people, we are talking about environment, we are talking about natural resources, we are talking about economy. Okay, so all these aspects are involved here, and to evaluate them, to study them, we need the help of traffic flow theory. Okay, I already told you there are three basic elements of traffic flow theory, which is these three. Okay, so since I'm using the other new book, they are using different letters here. So flow is represented with Q, and density is represented with K, and speed is represented with U. Okay, this is more common, by the way. In most of the books, you will find this. Okay, the traffic book is an exception. It's easier as well, but anyways. Okay, so flow is the equivalent hourly rate of traffic passing in a unit time. Okay, number of vehicles passing in a unit time. When you convert it to hourly rate, it becomes flow or flow rate. Okay, clear? So for example, you counted vehicles for 15 minutes. Okay, so that will be your N value. Okay, N is what you observe in the number of minutes you have taken traffic. Okay, T is the time for which you observe. So you observe for how many minutes? In my example, 15 minutes. So T is 15. Okay, or you put it in hours or seconds or whatever. Okay, so in this formula is in seconds. In this equation, T is in seconds. Okay, so you convert 15 minutes into seconds. There. Okay. So Number of vehicles you observed and the time in which you observed. Okay? So this will become vehicle per second, right? N upon T, vehicle per second, right? And then you multiply with this. So it becomes what? It was per second. Now it is per hour. Clear? Okay? So this Q is basically the rate for 1 hour. It's not actually 1 hour. What number? Okay? The Q is actually the rate for 1 hour. Because actually your T was less than 1 hour. This T is less than 1. That's why we did the conversion, right? If T is 1 hour, then this will be 3600, this will be 3600, right? You will get the same value. Clear or not? Any problem? Okay. So Q is the flow rate and it's a converted value. It's a converted value to 1 hour. It was actually less than 1 hour, converted to per hour. Clear? Okay. Then we have density, also called as concentration of traffic, traffic concentration, traffic density. Okay, and we define density as what? What is the definition of density? Yes, density of cement, density of steel. Yes.
How much crowded is
How much?
crowded or quality? Like in the highway, how much cars we have? How many
Yeah.
vehicles?
Okay. So, but if I say, give the definition of density of material, what would you say? How do we define the density of material? Density of concrete. We have taken concrete, right? Density of concrete, materials. How do we define it? Density equals to what? It's a ratio, right? Ratio of what? Ratio of? Let's speak loudly. Kg per meter cube. Weight per meter cube is what? Volume, right? Okay. So traffic density, we replace the weight with traffic, number of vehicles, and we replace the volume with length. Okay. So traffic density is a ratio of number of vehicles per unit length. Okay. Traffic density, traffic concentration, number of vehicles per unit length. Got it? And the length is miles or kilometers. We cannot create a small unit. For example, if you did vehicles per meter, how many vehicles you can have in 1 meter?
Bicycle.
Huh?
Bicycle.
Bicycle. A bicycle is more than a meter, right? Okay. My daughters have few vehicles which will fit in 1 meter, but they cannot ride it, right? Okay. So it's always a large unit. So density, you always take a large unit, otherwise the density will be very, very small. Okay, something in fractions. Okay. So this is what is written here. And speed is, speed, you know speed, right? It's the ratio of what? Distance over time. Okay. So all three of them are ratios, right? All three of them are ratios. Flow is a ratio of what? Flow is a ratio of
Number of vehicles over time.
number of vehicles over time. Okay. Density is the ratio of
Number of vehicles and
number of vehicles and length. Okay. And speed is the ratio of time and what? Ratio, right? Distance and time, right? Okay. So all three of them are ratios and all three of them involve vehicles, time and length, right? All three of them have vehicles, time and length. Vehicles per time, vehicles per length, length per time, correct? Okay, so now you can imagine they are interrelated to each other because they are using the same units, okay? The units are related to each other. Okay, so for example, if you have number of vehicles which are passing in 15 minutes is 500. Okay. So if I go back to this slide, which of these things I observed? 500 vehicles, 15 minutes. So I'm talking about vehicles and time. Which of them? Flow. Okay. So we have this equation for the flow. Okay. Now which one of them is 500 and which of them is 15 minutes? And the equation. N is 500 and T is 15 minutes. Clear? Okay. So what will be the flow rate in this case? How much?
2000.
Yes. Okay, so now it has become vehicles per hour. It was per 15 minutes, now it is per hour. Clear? Any problem? Clear? Okay. The next parameter we are talking about, we will talk about is speed. Okay, so we are talking about flow, now we talk about speed. Okay. When we are talking about traffic flow, vehicles have different speeds, right? All vehicles do not travel at the same speed. And even one vehicle does not travel at constant speed. Even if I look at one vehicle only, the speed of the vehicle changes, right? From one point to the other. Okay? So there are many values of speeds. So when we take the entire traffic flow, we will take the mean of the speeds. Make sense? Okay, because we have so much variation. So there can be two types of mean speeds. We can have time mean speed and we can have space mean speed. Okay. There is, you can see the equations over here. The equations are different. Okay, but what does it mean? So this one is what we call as the arithmetic mean. The simple mean, what you know. Okay, summation upon the number. Simple arithmetic mean. Okay, so that is time mean speed. So if you took 100 values of speeds and did the average, like summation upon number, that's called time mean speed. Okay, and then we have the space mean speed, which is the harmonic mean of this. So it's not a simple addition. Okay, what we are doing is this thing. Okay, U is my speed and N is the number of vehicles I observed. Okay, so here I was doing simple summation of U upon N. Here I am doing something else. Okay, I am taking the summation of inverse of speed and then N divided by that summation. Okay, so this is what we call as the harmonic mean. This thing which you see here is called the harmonic mean. Okay, so you are basically taking the mean of the inverse, not the mean of the actual values. Got it? Clear? So, if you are doing the mean of speeds like this, it's called the time mean speed. If you are doing the mean of speeds like this, it's called the space mean speed. Clear? Okay. This one is supposed to give you the speed, mean speed over a point. Okay. This one is supposed to give you mean speed over a point. Okay. And this one is supposed to give you mean speed over a section. Okay, over a distance. Okay, so this one is not a point, it's a section. Clear? Okay, so now you know the calculation is different. Okay, and their use is also different. Okay, the formulas are different, and the use is, this one is for a single point, and this one is for an entire section. Okay, clear? So, you can calculate it in this way as well. Okay, now this one works if you didn't use a speed gun or a speed device for measuring the speed. Then you can do it like this. If I ask you to measure the speed, and you don't have any speed camera with you, so you don't have a speed device with you, okay, how will you measure the speed? The speed is what? Distance over time, right? Okay. So now, what you will do in the field? I have to measure the speed of the car. I don't have a speed gun. What I will do? Measure the distance and the time, right? So you have a distance and you have taking the time. Okay. And you calculate the speed using distance upon time, right? Okay. So this equation is for those cases. Because section can, if I have a speed gun, I will use the speed gun to take the speed directly, right? It will give the u value directly. Okay. But if I don't have a speed gun, if I don't have a speed camera, then I will do distance upon time. Clear? So I have a distance, I don't have a u direct. I don't have this value direct. I have L for every vehicle and I have its T, time. Clear? So in that case you will use this equation. Okay? So both of them are for space mean speed. Okay? For the section. But it depends upon how you are taking the speed. If you took the speed directly using a speed device, sensor, then this one, because you have u already. Okay, if you did distance upon time because you are using a stopwatch instead of a speed device, then you will do this. Okay, so you will use time and you will use the length. Clear? Okay. Now you can see I am doing summation of what? Time. Am I doing summation of L? No. That means L is constant. So I have taken time for 100 vehicles. Or for all 100 vehicles, the distance was, see, this is how I normally do, right? I am standing here for this section, I need this speed. So I will just take one length, right? I will just play with the stopwatch. I will not take the distance for every vehicle. Okay? It will be problematic. Okay. So let's say at a particular time on the highway, the speeds of 3 vehicles are these 3 values. They are given in both units. You can use any of them which you want. So we have to calculate the time mean speed and the space mean speed. Okay. Now for space mean speed, I'll use which equation? This one, right? Because I have the u values correct. Okay. So for time mean speed, simple mean, right? Okay. So what is my time mean speed here? Okay, for space mean speed, you will do the harmonic mean. So you have 3 vehicles, 1 upon this is for the space mean speed. How much is that? What did you say? Okay. So now you see the values are not completely same. They are very similar. It's not like one is 40, the other one is 50. They're very similar, but they are not exactly same. Okay. Which one is lower? Space. Okay. So this is always supposed to be lower. Space means speed is always supposed to be lower. Okay. And the logic is space means speed is for the section, remember? For a section. Okay? So for a section, in a section, your speed has up and down. Okay? So this up and down will cause less average. Getting my point? Okay? So this small difference in both values is because of the variation of the space mean speed in the section. Okay? Clear? Okay. Second example, we have space mean speed given. US is given, which is this much. Again, values are given both ways. They have given me 2 vehicles, speed of 2 vehicles. Average is given, the speed of 2 vehicles is given. They are asking for a third one. Okay? Okay? So the 2 values are given, which are 45 and 40.4. So we have 3 values like this. This one is 45, this one is 44, 40.4. This one is unknown and the average is given, the mean is given. It's the same mean which you found in the earlier example. How much is the speed of the third vehicle? Okay? Any problem? Any question? Okay. Now just to be clear, we always call them mean speed, we don't call them average speed. Okay, this is what you will find in all the books. Okay, because although we take mean and average to be the same, but statisticians, they say no, they are 2 different things. Okay, average could be same as mean, but average could be something else. Okay, so we are following their advice and we are calling them mean. Okay, but if you talk about time mean speed, the time mean speed is same as average. Okay, but this one cannot say harmonic average. So there is no such thing as harmonic average. Okay, another parameter which affects speed is the headway. Okay, what is the headway? It is the time interval between 2 wheels. Headway is the time interval between 2 wheels. Okay, so I am standing at point A. Okay, a vehicle passes me. Okay, so this is vehicle number 1. It passes me at 0 seconds. Okay, the next vehicle number 2 passes me at 5 seconds. Okay, so this time interval is my headway. Okay, clear? And you have to keep in mind your reference point should be same. When you are measuring the headway, your reference point for the first vehicle and the second vehicle will remain the same. what? It means two things. So I look at the first vehicle at this point, right? Okay? I look at the first vehicle at this point. So I look at the second vehicle on the same point. I cannot move. Okay, because this will disturb my activity. Secondly, okay, a vehicle, when I say vehicle past point A, what does it mean? When I say vehicle past point A, what does it mean? Did the tires pass point A? Or did the vehicle completely cross point A? Or did the vehicle just came to point A? What do I mean? That can mean different things, right? Okay, maybe he is saying vehicle past point A, he means vehicle already crossed. Okay, you are saying vehicle past point A, but what you mean is the tires have crossed. They are not the same thing, right? Okay, so when you are measuring the headway, you have to make sure that what you did for the first vehicle is what you are doing for the second vehicle. Okay, so for him, let's say he is saying, I will start noting down when the vehicle has crossed. Okay, now he has to wait for the second vehicle to cross as well to note down the headway. Got it? Okay, you cannot say no, the first vehicle crossed, the second vehicle, I just look at the front tire. No. The first vehicle you started the time when it crossed full. So you will note down the time when the second vehicle crossed full. Okay. If she is doing it and she is doing it only for the front tires, the first vehicle, he will note down. Or if she start the time when the front tire passed. When will she stop? When the front tire of the second vehicle had passed. What the point? Okay. So it must be the same reference point, otherwise your headway value will not be the same. Okay. So this thing which I explained here is called as time headway, represented with H. Okay. Time headway. And then we have a space headway as well, which is the distance between two vehicles. So time headway was the time between two vehicles, right? And distance headway is the distance between two vehicles. Clear? So if vehicle 1 is here, how far is vehicle 2? So this is the space headway. U or which? D. Yes. Okay. Clear? Any questions? Okay. So what was time in headway? What was time headway? Time between two vehicles, right? And space headway is distance. Clear? Okay. Now, if the time between two vehicles is longer, the space between them is also more, right? Okay. The other vehicle is far, so it will take more time to come, right? The distance is more, if the space is more, the time head will also be more. They are related, right? Then, okay. I believe we have the explanation of this diagram coming later on. Otherwise, we will have a look. But for time headway, we measure it in seconds. Space headway, we measure it in feet or meters. Okay. Smaller units. Smaller units. Okay. For headway, we are using smaller units. For flow and density, we are using big units, right? Per hour, per mile, per minute. Even for speed, per hour and mile, right? Mile per hour. Okay? Because this is how vehicle speeds are. And I already gave the reason for density being in miles. Because we cannot do it in meters or feet. It will be very small. But headway and spacing, if I measure headway in hours, what will happen? In this case, the headway is 5 seconds. If you convert it to 1 hour, it will be 0.00 something, right? So again, we are trying to avoid the small fractions. Alright? Okay. So that's why. Okay, so this is the diagram I was talking about. It's coming directly here. So this is called a time space diagram. You can plot it by using and there are simulation softwares available now. So you run the simulation, okay, and you can plot these diagrams for you. Okay, it will simulate the flow of each vehicle separately from point A to point B, and will make these diagrams for you. Okay, so we are calling them as time space diagram, right? Okay, so we have time on the x-axis, distance on the y-axis. Okay, time, distance. Okay, each of these lines represents one vehicle. Okay, each of these lines representing one vehicle. How many vehicles have been plotted here? 6. Okay, so you can see for each of them there is a different slope, right? Okay, and in some cases, for example, vehicle number 3 and 4, you can see a break here as well, right? Okay, so each vehicle can have its own trajectory, its own movement, how it is moving in the traffic. Okay, it can be completely different from the other. Okay, so what is happening with vehicle number 3 is very different from these two vehicles, right? Okay, where the speed is lower and this is happening and so on. Okay, so if so what did we do? We took the distance and time values for these vehicles. Okay, so when the time was 0, how much was the distance? When the time was 1, how much was the distance? Time was 2, how much was the distance? And so on and so forth. Okay, for each vehicle. And then we plotted it and we joined it with a line. Okay, clear? So the software can do this for you. It will do the simulation, it will plot the lines and so on. Okay, now what is this showing? It is distance and time, right? Distance upon time is speed. If you take the slope, distance upon time, it will become speed. So if I take distance upon time here, it will give me the speed of the vehicle here. Okay, in this distance. Clear? Okay. If I take, so this is vehicle number 1, this is vehicle number 2. Okay. If I take the difference between them on the x-axis, what is my x-axis? Time. So if I take the difference between two vehicles in time, what do we call it? Time head. Okay. If I take the difference between them on y-axis, y-axis what? Distance. So the difference in distance between two vehicles is what? Space. Clear? Okay. So this diagram, after it is plotted, can give you head-end spacing between vehicles. Okay, and you can take it here, right? You can take it at this point, at this point, at this point. They are not the same, right? So between each pair you can have multiple values. Okay, and same thing for the horizontal as well. You can have different headways. Okay, so the time-space diagram gives you speed. You take the slope, you get speed. You take the difference, you get head-end spacing. Clear? Okay. Another thing which you can get from here is this thing. Now what is happening here? Time is increasing, right? Goes from T1 to T2. Is the distance increasing? No. So time is moving, but the vehicle is stopped. Okay. So now I can take this time and I know for how long the vehicle has stopped. Okay. We call it delay, right? This is my delay. So this diagram can give you basically all these things. Okay. So what are the things we can get from this diagram? Speed, time headway, space headway, and delay, stop delay. Okay. So these are things you can get. But this diagram is basically telling you how the vehicles progress or move on the highway, how they are moving. Okay. And then you can see the relationships between them as well. Okay, so what can you comment about the speed of vehicles in this diagram? We have 6 vehicles. Okay, so what will you say about their speeds?
Mostly constant speed.
Huh?
Mostly constant speed.
Mostly constant speed, yes. There are some breaks, but they are very few. 4 of the 6 vehicles don't have any change, right? No change in slope for them. That means the speed is constant. Okay, even for the other vehicles we have just one change. Okay, so most of the vehicles most of the times are going at constant speed. Okay, what else? Anything else?
Fewer delays.
Huh?
Fewer delays.
Fewer delays. Okay. There are only 2 vehicles which had some delay. The others kept on moving, right? What else? If you look at 3 and 4, look at 3 and 4. Okay. Both of them have delay, right? Both of them have delay. Okay. But there is some change in them. Three and 4 are not the same. We have a change in speed. We can see there is some delay as well. It's not the same. What's happening? What's the main thing you can see between 3 and 4?
But increase the speed
Hmm?
while number 4 stop for a while and
Yeah.
move.
And number 4 is? You were talking about 3 or 4?
Three,
This is 3. The top one is 3.
three stop for a while and continue moving.
And
While 4 decrease the speed but
Yes.
still moving.
you can see a horizontal portion here. Okay, so it's actually stopped. But this one, it's not completely horizontal, right? So there's a change in slope. The slope is decreasing, so the speed reduced, yes. But it did not stop. You got my point? Okay. So this is also delay. Slowed down. It is also delay. Okay. But it's not stop delay. This one is stop delay, right? And this one is a delay, but not stop for stop. Okay. Now, if you look at these two, 3 and 4, can you guess what happened between them? Between 3 and 4.
The first car stopped. So
Yes.
the first car
Reduce the speed, and then what happened? Yeah. The third car stopped because of any reason. So there was a complete break. The car behind him saw it, okay, and started to slow down. Okay. But before it reached that point, the third car started moving again. You see that this portion is very small. Okay. So before this car reached the same point in distance, you can see that this is the distance, right? This is the point. So before this car reached this point, it already started moving. So this one didn't have to stop completely. So if this was longer, this one will also stop. And this one also stops, and if this stops, then it will reach the next car, right? Because now this driver will see, oh, the car in front of me has stopped. Okay? But what happened right now? This guy slowed down. This guy said, I don't care until you stop. Okay? I kept on moving. Okay? You get my point? So this is what this diagram can tell. Now you see here, from this diagram, you can calculate the speed, you can calculate the time, you can calculate the spacing. Okay? You can find out where the car stopped, for how long it stopped, and because of this stopping, what happened to the other car. What happened? Okay? So this this is the whole concept of traffic flow theory, going back to the first one. Okay. This is giving you a complete picture, right? This guy did this, then this is what happened to the other guy. And if this guy did it for longer, this is what can happen to the other guy. Got it? Okay, so okay. So for example, if I want, so this is now for other 4 cars, and we are trying to answer these 4 questions here. Okay, we want a space headway between vehicle number 3 and 4. You can see the vehicle numbers here. Vehicle number 3 and 4 at time 6 seconds. Okay, so I'll come at time 6 seconds. Okay, so when the time was 6, how far were these vehicles from each other? Okay, so go from here, time 6. Okay, I have to check if I do something here with it. Okay, now you can erase it. Yes. Okay, time 6. Okay, when time was 6, vehicle number 4 was at this distance. Time was 6, vehicle number 3 is at this distance. Okay, so what is the spacing between them? How much? This is 240 and 240. No, not 240. This is between 240 and 320. What is the mid of 240 and 320? This one is 560. Okay, this one is 560. This one is between 320 and 240. 280? 280, yes, 280. So 280 and 560. How much is the spacing?
Sorry?
280. Okay. The speed of vehicle when time was 3 seconds. Speed of vehicle number 3 when the time was 3 seconds. Okay. So here. Easy, right? What is the speed of the vehicle here? It's a straight line, right? It's a horizontal line. So no slope. Slope is 0. That means speed is 0. The vehicle is stopped. Okay. Speed of vehicle number 1. What time? What time? Huh? Mean. A time matters here. Vehicle number 1. Speed of vehicle number 1. The time matters here? No. Okay, because the speed is constant. Okay. In vehicle number 3, speed is not constant. So if I change the time, the speed will change, right? Okay, vehicle number 1 doesn't matter. Okay, so you can take the whole thing. It doesn't matter. You can take the slope over here or here or here. It doesn't matter. Okay. So if you see from 0 to how many seconds? Whatever number of seconds. Okay, so I will take the distance easier. Okay, so from 0 to 880. If I come here, okay, from 0 to 880, it goes in here, okay, in 7 seconds, I believe so. Okay, so 0 to 880 in 7 seconds, not 7. Yeah, this is 7. This is something before 7. 1, 2, 3, 4. 6.8 seconds. So it reached 880 feet in 6.8 seconds. So how much is that? Okay, 7 is here, slightly on the other side. Okay, between 6 and 7 you have 5 divisions. Okay, clear? Any problem? You understood everything? Okay. Yes, how much?
The 880 minus 640,
Why?
because it didn't start from 0.
Sorry, yeah. Okay, good point, yes. You cannot take because it did not start from 0. Vehicle 1 did not start from 0, right? It started from here. Okay, so it reached 880 from here. So what is this between these two? So this is 600 now. From here to here is total, and this is in the middle. So this is 600. So from 600 to 880. Come on. Okay, but the time is from 0. Started from 0.
41.
This is feet per second, okay? Because you took the units in feet per second. Okay, you still need to convert it to miles per hour. Okay? Clear? Any questions? Any problems? Okay, so we stop here.